Hi, welcome back. We are working on Unit 6A. We're working on circles, and with Section 4, we're kind of switching gears a little bit, and we're going to be working on equations of circles, and we'll do this for 2 sections. In this first section, we're going to be given the equation of a circle and have to find the center and the radius. We're going to graph a circle, and then given the center and the radius, we're going to write the equation of a circle in standard form. So let's talk about standard form first. So standard form of the equation of a circle looks like this. We've got these two quantities squared. We have x minus h quantity squared plus y minus k quantity squared equals r squared. And if the equation, if the circle is actually centered at the origin, h and k could actually be 0. And so we could just see x squared plus y squared equals r squared. So the center of the equation is hk. And the radius can be found by taking the square root of r squared, which is r. So notice the center, we take the opposite signs. So minus h comes out as positive h, minus k comes out as k. So in a circle, the center is our hk, and then our radius is r. Radius, remember, is the distance from the center to any point on the circle, which would be just an xy. So we're going to start by practicing finding the center and the radius, and then we'll show you how to graph. So in problem number 31, we have a equation x squared. Okay, so that quantity does not have an h. There's no quantity squared, so we can just let h be 0. So for our center, we're going to have our h is going to be 0, but our k will be the opposite of negative 4, which is positive 4. So that's our center. And then to find our radius, we're actually going to take the square root of 25, which is 5. And now we're going to graph it. So the center is at over 0, up 4. So 1, 2, 3, 4 right there. And then our radius is 5. So what we can do is just kind of go out 5 in all directions. And that'll give us 4 other points to draw through. So there. Go 5 up. 5 left. And 5 down like that. And now we can draw our circle. My circles are going to be kind of lumpy. I'm not real good at drawing them, but, you know, there's our circle. Okay, that's a circle with center at 0, 4, and a radius of 5. So let's try another one. In the next problem, number 32, our center, our h value actually is a fraction. You can write it as a decimal if that's easier for you to graph it that way. So we can say that we're going to be at 2.5, and then y plus 3, we're going to be at minus 3. So there's our center at 2.5, negative 3. Then our radius is the square root of 9, which is 3. So we're going to go over 2.5 and down 3. So we're going to be like right about there. Let me make this a little bigger. We can see it. And then we have to go out 3 in all directions. So there's point, 3 to the right, 3 up, 3 to the left, puts us right there. Oops, yeah. And then 3 down, right there. So a little bit smaller circle this time. And there we have it. So let's see if you can try one now. Actually, let's do 33 first, then we'll have you try 34. So for 33, we have a center at negative 3, negative 1. Okay, we changed the signs. Our radius is the square root of 20. So it would probably be best to actually take the square root of 20 and approximate it. So if we do square root 20, we get about 4.47. So we'll say about 4.5. So it's just going to be an estimate. So now we can graph at negative 3 and negative 1. There's our center. And then we'll go out 4.5 in all directions. There we go. We'll draw our circle. Again, kind of a lumpy circle. Hopefully yours look nicer than mine. Now I'll have you try number 34. So go ahead and pause the video and see if you can identify the center and the radius and draw your circle. So our center would be at positive 2, negative 3, and our radius would be at 4 for the square root of 16. Okay, so now we can graph over 2 and down 3, and then 4 in all directions. There we go, and there's our circle. Okay, so that's basically how we graph a circle. So that's the first part. The second part of our lesson today is going to be about writing equations of circles. So on this page, we're going to be doing a lot of write the equation of a circle in standard form. So let's go ahead and get standard form back up here so we know what it looks like. Remember, that's going to be x minus h quantity squared plus y minus k quantity squared equals r squared. So in problem 35, they give us the center and the radius. They basically have given us everything we need for this problem. So we're going to plug those in. So x minus negative 15 is going to make it x plus 15. Okay, and that's quantity squared. And then plus y minus k is y minus 12. Quantity squared equals the radius squared, 2 squared, will give us 4. And there's our equation. So when they give you your center, that's your HK, your radius is your R, you just had to square it. 36 is below, and we have a picture. Okay, now for this picture, we're going to go ahead and identify the center. So let's see if we can figure out exactly where the center is on this picture. It looks like it's about here. Let me test it out. Let's see. So I go up 1, 2, 3, 1, 2, 3, 1, 2. Yep, it looks like it's equidistant from all parts of the circle, all points on the circle. And that distance looks like it's 3 units. So now we have our radius of 3. So we have our center. Okay, so let's just write that down first. So we know our center is actually at negative 1, positive 4. And then we know our radius is 3. So now we should be able to write our equation. So x minus negative 1 is actually x plus 1 squared. And y minus 4 is y minus 4 squared equals 3 squared, which is 9. And there's our equation. So not too bad for those two. When we get to 37, however, we have a little bit different situation. They didn't give us the center, and they also didn't give us a way to find the radius. So we're going to work through this one a little differently. They gave us the endpoints of the diameter. So think about where that would be. So endpoints of a diameter might be here and here, or it could be like here and here. So if they give you the endpoints of a diameter, you could use the midpoint formula to help you find the center of the circle. So that's what we're going to start with. Let's get our center. The way you find your center is you're going to use your midpoint formula. Let's review that formula really quick. So to find a midpoint, we add the x's. So we go negative 16 plus negative 14, and then we divide it by 2. And then we do the same thing with the y's. So we do negative 15 plus 9, and we're going to divide that by 2. So that's how we're going to find the midpoint of any line segment. We add the x's, divide by 2, add the y's, divide by 2. So that's going to give us negative 30 divided by 2 and negative 6 divided by 2. Okay, so now we know the center of our circle is going to be at negative 15 and negative 3. So having the center is great because remember, your center is your HK. So we could actually go ahead and plug that in and we'll almost have our equation done. We do x minus a minus 15 is x plus 15 squared plus y minus a minus 3 is y plus 3 squared equals r squared. So we still don't have our r, but there's a pretty easy way to get that r. Since you are working with 2 points on the circle, you could actually pick either one to plug in. So maybe I'll pick, this one here. We'll say, okay, let's plug that in for x and y. Okay, and then we'll be able to solve for our r. Okay, so let's change colors right now because we're going to switch that up a little bit. So let's go ahead and plug in the negative 14 for x. So negative 14 plus 15 squared. And then let's put in the 9 for y. 9 plus 3 squared, and that will give us our r squared. Okay, so we really just need to fill in this r squared. So if I can simplify and get my r squared, okay, I don't even need to square root it. I'll just have r squared. So it looks like we're going to get 1 squared plus 12 squared is going to be our r squared. And our 1 plus 144 is our r squared. So our r squared is 145. Okay, now I just have to replace that into the problem that we already worked on. So x plus 15 squared plus y plus 3 squared equals 145. And there is the equation of our circle. Okay, so always keep your r squared, don't square root it, because remember your equation wants an r squared. Okay, the standard form of your equation wants an r squared, so you don't need to root it there. Now if you're going to graph it, you would want to root it. Okay, so we'll give you a chance to try number 38. So go ahead and pause the video, try number 38, write the equation of the circle in standard form. All right, well, our center, remember, is our HK, and our radius, of course, is our R. So let's go ahead and fill this in. So x minus 6 squared plus y minus negative 8, which is y plus 8 squared, equals 8 squared. So we'll do 8 squared, and we'll get 64. And there's our equation. So we have one last problem, and it says, prove or disprove that the point 1 square root of 3, okay, so that's a point, well, that would be xy, lies on a circle that is centered at the origin and contains the point, okay, there's another xy, 0, 2. So we want to prove or disprove that the point, this point over here, actually lies on a circle. So we're going to not do anything with that point yet because we need to actually get the equation of the circle first. So they tell us the center of the circle, which is 0, 0. So it's just x minus 0 squared and y minus 0 squared. So that's really just x squared plus y squared, but we don't know the r squared. We still need to find that. Okay. Remember, that's your h, that's your k. So what we could do is we could plug in the point that we know the circle contains. Okay, we know the circle contains this point, 0, 2. So let's do that. Let's plug in 0 squared plus 2 squared, and that'll give us our r squared. So 0 squared plus 2 squared is 4. So the equation of our circle is x squared plus y squared equals 4. And we want to know, does the point 1 square root of 3 live on that circle? So let's check. Let's check to see if 1 square root of 3 lives on that circle. So if I plug in a 1 and for x and square it, and I plug in a root 3 for y and square it, do I get a 4? So that's my question. If so, then that point does lie on that circle. So 1 squared is 1, and square root of 3 squared is 3, because the square and the square root will cancel each other out. That does equal 4, so we got a good. So yes, the ordered pair 1 square root of 3 does lie on this circle. Okay, so that's just a little bit of a challenge problem, a little different. So that's it for equations of circles on the coordinate plane and also standard form. And we'll pick up with section 5 next. Thanks, everybody. Have a great day.